Today's webinar is Don't Trust But Verify, Tab Lessons Learned from a Commissioning Provider's Perspective with Gary Haydu and Mark Gelfo. Gary Haydu is a certified commissioning agent at TLC Engineering Solutions, bringing a wealth of experience to his role. His career in the HVAC and commissioning industry spans nearly 2 decades, with a significant portion dedicated to HVAC controls. This extensive background has equipped Gary with a deep understanding of HVAC systems and controls technology. Mark Gelfo is managing principal for TLC Engineering Solutions and has been practicing electrical engineering, commissioning, and energy management for more than 30 years. Mark has specialized in design and commissioning of high-performance buildings his entire career. Mark is a professional electrical engineer licensed in numerous states, a LEED fellow, a certified commissioning agent, and a certified energy management professional. Mark also serves on the ACG Board of Directors, currently as president, and is on the NFPA 110-111 Technical Committee. Without further ado, I'd like to hand it over to Mark and Gary to kick us off.
Thanks, Cassie. So as Cassie said, the title of our presentation today is Don't Trust But Verify. It really says it all right there in the title. But this is the slide that I really enjoy. This is a great picture of Gary. It's not typically what he looks like because he doesn't normally smile like that. But we're not here to bash test and balance or test and balance professionals. Quite the opposite, in fact. And we're going to talk about how interrelated test and balance is to the commissioning from our perspective. But we're going to share some things that we've seen in the field that bear addressing. That's just us. That's our corporate shots. This is what Gary looks like usually when he's out in the field talking when subcontractors and test and balance and controls guys tell him that everything is working right yesterday. But anyway, you can see our learning objectives there. We're going to talk about red flags from tests that we see during test and balance work. Like I said, why functional testing and verification matter. And then proactive commissioning and collaborative test and balance, which is really a way of saying that we treat it not like a relay race where test and balance then hands it off to commissioning, that especially on that side that they're really interdependent, and if we don't have good test and balance, then we're not going to have good commissioning, or we're going to be starting in the hole. So we want to lift up the entire process. So with that, I will turn it over to Gary.
All right. Well, we want to say, why is tab and commissioning important? Obviously, we know why test and balance is important. We know why commissioning is important. But what we see is happening out in the field is occasionally, as a commissioning provider, we'll get a call after a project completes when owner starts to move in and they have hot and cold areas. And typically when we start investigating it, even though we have a test and balance report, even though we commissioned it, maybe not every area was commissioned, we find that tab wasn't done correctly, or there was an issue with tab. And furthermore, we kind of just go through and we start to figure out, what did we miss? And, is there something in the report? So I want to touch on 3 different types of reports that I typically see. I see a good report, a bad report, and one that we call the pencil whipped report. I like to start off good. So a good report, typically when I open it up, I want to see overall findings. How's the system operating? Is it operating to design? Is there issues? What are the issues? So we can quickly notate that and see it quickly. More times than not, we're seeing a lot of missing data, empty summaries, empty test procedures, not even project names. These I consider a bad report. Then I go back to a good report. I want to make sure all the equipment is there. What equipment they use, is it listed? Does it have the calibration dates? Does it have the certificates of calibration? These are good reports we typically do see. Then I run into where I see the calibration reports, but then I start looking at dates, which we all overpass. We kind of quickly look at them. And in this particular case, I had a report, the balance was done in April of this year, and all the calibration certificates expired in December. So that's a little concerning. Was it a copy and paste on the test and balance report? Maybe. So we had to get clarification from the actual test and balance contractor. On a good report, like when we're starting to talk about terminal box test data, we want to see everything. We want to see the design data. We want to see the prelim data. We want to see the final data. BAS calibrations, I love seeing those. We barely see them on reports. It's nice when they're added. It does keep a good track record of it, and it helps us later on down the line when we're trying to troubleshoot. And then any issues that might be with that terminal box should be listed in that terminal box data. And in this particular report here, you see it's got all the data we're looking for, and it's very thorough. It even has the filter condition is dirty, which is good to be notated. On reports we get typically where we're missing a lot of data, no design data, no test data, prelim test data, just blanks. And then on other areas, like on the one to the right there, we have a supply section that doesn't have the prelim data, but then we have the return section right below it. It's got it. Why are we missing this data? It's super important for all of us. And then the most interesting one is what we call the pencil whipped report. That's when things are too perfect. Every diffuser reads 100% to design. Somebody just copied and pasted. You could tell it. It's super easy to figure out. Calibration factors are a big one for me. If I see a calibration factor that either matches a controls calibration standard, well, did you do your test and balance? It should be a little different, even if it's just off by a 0.09. Or calibration factors that are really off and just crazy numbers, like almost like somebody didn't know what they were putting in, or maybe there's a control issue that's not even test and balances issue. So that's usually what we see as a pencil ripped report.
So Gary, have you seen any correlation between, are we talking about preliminary reports that have already been reviewed by the EOR? Do you see any correlation there?
Sometimes, not. So engineers usually look them over and then just hurry it up, got them, I got a report. They're looking at airflows, make sure it matches their design. But yeah, I don't, every project's different. We don't, not one project's the same, and we see different things all the time. So let's talk about tab verification. This is the verify part of the presentation, and it's really important. One of the things to note that all tab professionals are not created equal. A certifying firm does not guarantee a certified technician is actually doing the work. We've seen that over and over again. I've also seen where we've had fantastic test and balance firms, and they do a great job. They're thorough. They're there when we ask them questions. So what is a tab verification? Tab verification, in our eyes, it includes all the time controls contractor and a test and balance contractor. We ask the owner usually to be involved. We ask the general contractor, the mechanical contractor. So if there's any issues, they're involved with us. So one of the things we like to look for when we start a tab verification is check the equipment that's being used. Typically, I like to see the same equipment that did the test and balance on a building be the same equipment that's on site. I want to check the sticker on it. I want to see that that sticker is the calibration and it's calibrated and we're using a valid device. Then I also utilize the data from the test and balance report during the verification to make sure that things match. So when I see crazy calibration factors in a BAS, either on the report or maybe not even on the report, and I'm looking in the BAS software, I want to find out why. What's going on? Is there something red flagging? In particular, this one here is a 10. This BAS software that was being used, their standard is a 1 correction factor. So a 10 is like super bad, that there's a problem. And actually, when we verified it, the control system showed it as a 9.6. So it wasn't even matching the tab report, which was kind of a bigger red flag at that point. Then as we dove in even further, we started looking at the box size, because typically, test and balance is supposed to go in, confirm the box sizes. The report will show the correct box size. But did the BAS get updated with the correct box size? So in this particular case, we were seeing high correction factors. The BAS was showing the box size as a 4-inch when it was supposed to be an 11.5-inch box. This causes a little bit of concern because obviously all of the test and balance for that one particular terminal unit is no longer valid because the box size was way off, which creates basically a nightmare of a situation. This goes back to why we get a call that says they're either hot or cold typically.
Yeah, I think it's worth mentioning this example that Gary's talking about was a building that was just about to be occupied, right, Gary?
That is correct. Actually, the owners were kind of in there a little bit, but they weren't fully occupied at that point in time. So this is one of my favorites. I think it's Mark's favorite too. In this particular situation, we have a test and balance contractor. We were going and doing tab verification. We did have a call that they were hot and cold in certain areas. And we asked him to go ahead and verify some flows on some diffusers. And as you can see in this picture here, he is using a 2x2 hood on a 4-foot linear diffuser. His other hood was actually just sitting outside the wall, which I have a picture on the left there. That would have been the proper hood to use. In this case, he was taking all of his readings with his 2x2, and the whole building was balanced with just his 2x2, and he never used his linear hood. So needless to say, this building had to be recalibrated with the proper equipment. So let's make sure, we need to verify that we're using the proper equipment, or they're using the proper equipment when they're doing test and balance, and also tab verification.
So, and when Gary challenged him on the use of the hood, he dug his heels in and said he's always tested it that way.
So that makes me a little concerned that, if he's always done this, and, if he's been doing it for 10 years, how many buildings are wrong or have issues, and everybody gets blamed, typically the controls contractor, and then commissioning, and then design teams, when it may not really be any of those issues. It's just a poor balancing at that point. So part of our tab verification typically is we do sampling. We would sample, say, 10% to 25% of terminal boxes. And in this situation, we went in and we had a tab report, and it said the tab report was dead on, almost design. We was at 529 for the tab report. So we did a sampling of these two drops, and one of the drops was reading 474 CFM. Design was 280. Well, something was wrong. We see that. We're looking at the BAS. The BAS is way off. Now our actual reading is almost 200 CFM more than what it was during the test and balance report. So that's a big problem. After further investigation, we were initially blaming the test and balance contractor that maybe they didn't do their job, or somebody didn't know what they were doing. We actually found out somebody from the owner team went back and adjusted the balancing damper, in particular this one, because they were too hot. So not everything's blame test and balance, but when we're going to do tab verification, we expect it to still be the same. But occasionally, owners and other individuals go in there and start manipulating systems after test and balance has been completed. So this is something to be aware of when we're doing sampling. Try to take a step back and figure out what's going on. And this particular building had to be rebalanced because of the owner kind of taking this in his own hands to move air around. So this one was interesting. We were on a job site. I had a test and balance report. We were starting to do tab verification, and we went into a bathroom, and we put the hood up there, and we had no airflow. So we took the actual diffuser down, and we found out the ductwork was never even connected. So in this picture here, you can see the gentleman on the right, he's holding the diffuser. It looked like maybe it was connected at one point in time. But in particular, it was a building retrofit. So that was existing ductwork that was cut off, and nobody ever tied in new flex. Well, in the test and balance report, they had a prelim of 58 CFM and then a final of 103. So automatically now I'm questioning the whole floor of, hey, was this really balanced? Because how do you get air out of something that doesn't have a connection to it? There's no air going into that diffuser at all.
I'd also like just to throw in there, with my engineer hat on, this is why commissioning, exists, right? This is obviously a thing that was not observed by the engineers, and, test and balance aside, why we need the boots on the ground in the field, why we do all this verification, because there's so many examples that we give, and then some that Gary has here, where just poking your head above the ceiling just really quickly just reveals so much.
Yeah, and one of the things, even myself, I do it, is when we have a hard ceiling or something like that, and there's no access panels, we don't take the time to actually get above the ceiling. And in this situation, this would have been totally missed if we didn't pick it as one of our sampling boxes that we were doing. And this is how we ended up finding it. So a similar note, we had another one where I'm actually taking this picture through the diffuser hole. It's a different box on the same floor where the ductwork wasn't even connected to the diffuser also, and it was just laying in the ceiling. So as you can see, the ductwork's there. It's just blowing air into the ceiling. But again, we have a test and balance report. Now, on this one, they didn't do any prelim readings, they only did a final and they said it was 105 CFM, which is crazy how you get 105 out of a diffuser that doesn't have anything connected to it, but it doesn't surprise me. So this one's not a test and balance thing, but you know, the things we see when we get above ceilings, I guess this sprinkler guy was a little too lazy and he said, I'm just going to go right through your ductwork. I don't care what it does, you know, and this is the way it's going to be. We never would have seen it if I didn't get above the ceiling and start taking a peek and seeing what's up there. So in this, we're going to go into like heating. It's very important that we test heats, especially when we're doing tab verification. We want to make sure we see a terminal box function on all levels. In particular, this situation here, we had a test and balance report that said they were getting 101 degree leaving air and they had 14 amps, which was the box design. Well, when I went to the box, I started questioning how did they get the amperage? Because we had a 4x4 electrical box just kind of sitting right in front of the disconnect for the terminal box. So there's no way they would have been able to get in there and actually take an amp reading. So that has to be false because I couldn't get in there and look at anything. And then upon further investigation, after we got the electrician to move that box and then we started testing the heats, we found out we couldn't get above 75 degrees and we couldn't figure out why. So we started looking at the control system, and in particular, stage 2 was not even wired up. So on stage 1, we would only get 75 degrees. As soon as we connected stage 2, we did get up to, I think it was closer to 100 degrees. So again, test and balance told me that this was all done. The report said it was all done. The engineer saw that it was all done. But when we're doing our verification, we're finding that this is not 100% true.
Gary, is it safe to say that the electrical portion of the test and balance is, you know, maybe not as important, but almost as important as the CFM readings? Because I know we spend so much time, and the engineers, a lot of times when they're reviewing, are really focused on the CFM values. Obviously, electric heat, it's pretty important, but even on motor spreadsheet, maybe I'm a little more sensitive to it since I'm a Sparky guy. But do you see don't we see the electrical information just missing sometimes?
Yeah, a lot of times we don't see the full data. One of the things that I see very frequently on tab reports is when we have a fan box, you know, a fan terminal box with heat, we don't ever have fan amperage or fan speed settings. Typically, it doesn't even mention anything that it had a fan. And that's super important for future test and balance or retro commissioning or retro balancing, whatever you want to call it, in buildings, to have this data to fall back on and say, this is what it was from day one when we designed and installed it. And I think it's super important to have the data. I love looking at electric heat because when I get a cold call, that's usually where my problems are, is the heat's not functioning. And there's a slide here where shows why heat's not functioning typically, and we'll get to that. But it's super important to answer your question, yes. So one of my biggest pet peeves, that's been something new on my radar, I didn't know anything about it, and I learned this from a good friend of mine, was the speed adjustments on fan terminal boxes. So obviously when fan terminal boxes come from the factory, they are set up to be default. Usually they're full max, minimum, whatever, halfway. Well, there's usually a speed controller somewhere on the box, you know, on the corner, top, bottom. In this case, it was on the bottom. And there's little stickers that go over the top of the pots that adjust the fan speed. So when test and balance is setting up the fan speed to design, they have to break that sticker. They don't peel it off. Nobody wastes their time. They just break the sticker. So there should be a hole through the sticker. So in this whole job site, I had no fan data. So this test and balance contractor didn't provide any data on what was going on with the fans. We barely got heat data onto this one. And we found when we went back and retest and balanced this building that the fans were not set up to design. They were completely off, and it kind of contributed to why they were having hot and cold areas. So every sticker in the building that we went to was not broken. And I think there was 50 fan terminal boxes total in this building, and every one of them was not adjusted and basically just bypassed by the test and balance contractor. So another thing we see very frequently is on terminal boxes, either fan terminal boxes or regular terminal boxes, anything with a filter, we've been seeing the wrong filter size. Now, that's not a test and balance fault deal. That's a mechanical fault deal typically. But as a test and balance contractor, as a commissioning agent, these are things we got to look for, because in this particular, the picture on the left, the filter's not big enough, which means this box is going to be compromised with potential dust or any other contaminants that can hurt this box or destroy it over time. And the person that's affected by this is the owner. So it's very important to make sure we keep an eye out and look for things like this. And, you know, if Test and Balance sees it, they need to make a note of it. It needs to be in their report saying there's something wrong with this. The same thing on the right-hand picture. We see a lot of times during construction that has multiple different phases or areas, they will blank off return grills or return back to the air handlers. In this case, we are final, the owner's moved in, and the owner's complaining about air problems and issues in the area. Well, their return was blocked off. It was never getting the return back to the air handler, at least in this one particular area of a first floor. And so it's super important that, again, we get up and look above the ceiling, like Mark said earlier, just kind of peek around during construction, during test and balance, during test and balance verification. So this one was another unique one. We had an owner area. It was actually a conference room. It was super cold. It was like 60 degrees. We got called in. We were looking around. We found out the control system wasn't firing on all cylinders. We weren't getting any heat. So we went back, looked at the test and balance report. Test and balance report looked perfect. 101 degree heat coming out of this electric box. So the more we dug into it, we got the mechanical contractor out there. We tore the box apart. We found from the factory the airflow tube that keeps the safety working actually melted against the coils. So the heat would have fired for probably a few seconds before it tripped. And we actually ended up having to replace the tubing. We had to replace part of the coils because everything kind of got shorted together and hurt the box itself. So how Test and Balance got the actual readings, we don't know. Again, one of those things that you just kind of shake your head at and hope for better in the future. So balancing, this is one of the biggest things we look for when we go out and we start looking at open ceilings when ductwork starts going in, is we want to make sure that there's balancing dampers on all the drops heading out. Typically, it's one of the last things that go in, or it is in, and then they start doing their flex stuff down to the diffusers. So in this case here, we had a piece of duct run, and the last portion of the run, we weren't brought in during the beginning. We were only brought in for the functional testing part and the tab verification. And we started noticing that this one particular area was having problems with airflow. So we went back to the tab report, looked like it was adjusted. We went above the ceiling, and we found out that this one particular, the one that's clouded, did not have a balancing damper at all. But somehow the test and balance contractor was able to take his 177 CFM out of this diffuser and drop it down to 130 after his final balancing. Maybe it was a coincidence, I don't know, but it was the same building we had multiple issues with, so we kind of took it with a grain of salt, and we went back and mechanical contractor added a balancing damper, and everything was rebalanced for this one particular terminal unit. Another thing to keep an eye out on is one install. So this is after test and balance was done, and we found construction media still on the filter rack for one of our terminal boxes, as this is the picture on the left, and it's also smashed up against the wall. In this particular situation, it was kind of a retrofit, so it was difficult to get these large boxes they purchased in there. So the mechanical contractor did the best they could, and they did a fairly decent job. But they forgot to grab some of the filters out of there. But Test and Balance and ourselves, we should have caught this. In particular, we weren't brought in on this project till they were having hot and cold calls, and that's when we started noticing they had some construction filters still everywhere, and things weren't right in this situation. The picture to the right is something we typically always see, where we've got ductwork, the flex duct that's kind of like just wrapped around conduit or bent or twisted or kinked. So in this situation, as you can see, it is kinked. So, you're not going to get your proper airflow. It's not going to work 100% right. So keep an eye out for things like that when we're above the ceiling and looking at things, especially when they're open, you can see them. So the next slide is something we don't see too often. This was actually caught by a test and balance contractor. He sent me the pictures because I asked him for some good stuff. And this is where somebody from the mechanical side didn't cut the hole all the way when they installed their balancing damper. So when they were trying to balance this, they couldn't close the balancing damper because it was hitting the sheet metal. This is something that I probably personally never would have found because we don't mess with balancing dampers, but it should definitely be found by test the balance if they're up there messing around. But it's pretty funny to see us. We went through the trouble of cutting a half hole instead of cutting it completely open. So the next photo was also sent to me by a test and balance contractor. As a buddy of mine. He went out to a job site to fix an issue that they were having in some kind of lab, and he went up on the roof and found that they had sheet metal screwed to the bottom of the outside air intake. And it turned out another test and balance firm was trying to get the airflows right for the outside air, so that this was their solution because the damper didn't function. But the owner wasn't aware of the actual damper being non-functioning, but in the end result, they weren't getting the proper airflow. Obviously, the airflow monitoring station that was controlling the damper wasn't able to modulate the damper properly. So in the end, they ended up repairing this whole unit, damper replaced, and got it back up functional and working.
This is such a funny example of people like really just staying in their lane, right? The test and balance was not concerned about, oh, he just wanted to get the airflow right, instead of saying, hey, you got a bigger problem here. We need to replace or fix the damper, and addressing the whole system. I don't know why people are like that.
Well, it's sometimes just get the job done, and that's
right. And on to the next thing, which again is another reason commissioning exists, because our job is to look at the whole big picture, right?
So this one is the most interesting to me. It was a very unique situation we had. Obviously, if you see the picture to the left, the top left there, it's a fan coil unit that's serving an electrical room, and everything looks normal. If you stare at it, it looks great. I mean, it's a coil, it's open, it's brand new construction, it was piped in great. But we had problems controlling the room. It was a little bit warm. It wasn't super cold. The valve on the BAS was saying it was 100% open all the time. So we went and got our thermal imaging gun, and we started looking at the coil, and we found that the coil from the factory, this was not anything the construction team did or could have done, was not piped internally correctly. So as you can see the picture all the way to the right, where only parts of the coil is actually cold. So the water was only flowing through two sections of the coil, and it wasn't actually producing or able to dehumidify and cool the room properly. And then the picture in the middle is the U-bends, where you could see where the bright blue portion of the U-bends is where it's super cold. That's where the water's flowing. And then obviously the middle, there's nothing flowing there. I know Mark's got a part of this where the contractor told me, I don't know if you want to say it, Mark, where about the room condition. And
well, yeah, this gets into, operations too. Obviously our job as commissioning providers is to look out for the future for the operations. And when Gary presented this, issue to camp contractor, he said, well, we're making temperature. It's cool in here. So I don't see what the problem is. This is like during construction, at the end of construction, in a IDF room, an IT room closet, where there's no equipment in there yet. So yeah, maybe it would have been okay for a little bit, but it's a year, 2 years, 6 months, whatever, after the building is operated or building is occupied. They got IT equipment in there. Maybe they expand and add more. That now suddenly we can't get the temperature in there, and the room starts to be 85 degrees, and they come back and blame everybody, probably us. I thought you guys tested this room. So I don't know if I don't think you mentioned it, Gary, but then after we found this one, he went to every other room in this building that had an fan coil unit, electrical closets, IT closets, to check to make sure that didn't have similar issues.
Yeah, and that's what I was going to mention that after you spoke, that we actually had some that were ducted fan coil units, but we wanted to make sure this wasn't a one-off. So we had access panels. They were already installed, so we just went up to the access panels, shot it with the thermal, made sure the coil was cold, and then moved on. And I think the project had either 20 or 30 fan coil units, so it didn't take us terribly long to go shoot them real quick. And but this is the first thing I've ever seen actually in real life. I've heard about it, so this was kind of unique to see, and it's on our checklist now of maybe we should just thermal image all of our fan coil units and coils just to make sure that we're getting proper water flow.
Yeah, you can't understate the value that the thermal imaging provides, not only for helping find the issue, but when we presented this to basically the construction team and said, here, this is what it actually looks like. It really told the story a lot better, better than, we just using words.
Yeah, and talking about test and balance did do their job on this unit. They had the water flow set properly. Everything was perfect. When they took their airflow readings, when they were putting their probe, they were most likely, because they said everything looked great, they were putting it in the spot that actually had the coolest portion of the coil. So nobody really was here to blame except the manufacturer sending out something like this. But everybody on the construction team was forward to it. They wanted to get it fixed, and the coil was replaced within a couple of weeks once the manufacturer sent a new one. So it worked out great for everybody. So talking about water flow, one of the great things coming out that's been out is a lot of these energy valves or pressure independent valves that are on like air handlers that a lot of customers are purchasing and maybe not utilizing their technology as much. We can get apps on our phone that can pull the data. So in particular, we had a school. It was actually a gym area that it wasn't cooling. The humidity was high. I think it was like 70% humidity, and it was 80 degrees in there. It was not doing its job. We didn't open yet. It was still in the construction phase, but we were getting ready to turn it over to the owner. Test and balance report saying, hey, we had 25 GPM, design is 25 GPM, but there has to be a problem. And we're not seeing the coil wasn't that bad. It was doing 20 degrees. We were seeing 59-degree discharge, but we weren't sure what was going on. Well, because these valves are smart, you could take your smartphone, you could hit it, and it tells you what's going on. So as a commissioning provider, we go up there and we get the data, and we find out this valve's at 100% and it's only doing 6 GPM. So in the end, we found that there was actually an air pocket in the coil. So once the mechanical contractor pulled the coil apart and we flushed the air through, got the air out of there, put it all back together, we were up at 23 GPM in particular on this coil, and everything started to satisfy, and the owner was happy. So and then the students were able to use their gym. So it's important to utilize the tools that we have, and if there is things that we can connect to as a commissioning provider, do it. Doesn't hurt anything. It also helps if stuff like this is brought into the BAS, and now that we've brought this to the attention of the owner, they now want to capture all these valves into the BAS, which they weren't doing. They were paying all this money for it, but they weren't bringing all this into the BAS. So one of the things we've been utilizing lately, and it's starting to really hit the market, is basically a connected commissioning, which happens during the construction and actually before tab, after tab, we run tests. And in particular, the situation I had, one of our tests came back and it said, hey, it failed. We have an issue with this one VAV. I got a tab report that says the VAV is doing pretty good. Well, it turns out the damper shaft was never even installed inside the damper, so the damper never functioned. So controls did their checkout, said, hey, there's nothing wrong, everything's great, this box is working, here you go, test and balance. Test and balance did their test and balance on it, and they said nothing was wrong with it, and the report showed nothing was wrong with it, but it was never connected. And thankfully, we were able to utilize, connected commissioning to kind of go through the whole system of over 100 VAVs and find this one particular issue that would have presented itself sometime in the future.
You want to explain a little bit more about what connected commissioning is and the insight that it gives us, to review remotely?
Yeah, so connected commissioning basically allows us to connect to the control system in the early stages during construction, because typically during the construction phase of commissioning, we don't have access to the BAS. Not typically, sometimes we get it. And so we don't know what's going on, or we get towards the test and balance. When test and balance finishes up, we still don't have access, or it's not on the owner's network. So connected commissioning utilizes, different software platforms that allow it to bring data into a different database, and allow us to see things. It also allows us to remote test things. And there's various different vendors out there that do it. And it really provides dramatic insight for us, because we're able to test a building at 100% instead of sample testing for terminal units, at least. So it really opens the eyes to any potential problems like this that could be out there in a project.
How many issues on the last school we did? How many issues did this approach point out?
So we ended up
number.
Yeah, well, we got right about 88 issues that were generated. A lot of them were duplicate issues. And a lot of them were not maybe mechanical like this one. We actually noticed that it was more along the lines of sequencing, where the unit wasn't being called during unoccupied modes, or during occupied going to heating mode, it wasn't working. So it really pointed out a good bit of issues from the BAS standpoint that weren't programmed. Really not much on the test and balance side, because in a control system, you can't really see too much what's happening on flows. You just assume what the BAS says is correct. So, but it did point out some various different issues with the sequencing.
And then that gives us the direction to know, okay, these are the boxes we need to really look at in the field and see what's going on.
Correct. So a lot of times, and there's 2 slides here. So we'll get test and balance will be finished. We'll go after test and balance, kind of just go walk a job site. And we'll find that the filters on the air handlers have never been replaced prior to test and balance. And that's one of the biggest things for us is don't start test and balance until a new set of filters is in and everything is functioning. And in this case, they've been in so long, they started to collapse into the coil. And that created some issues for the ownership, because they had to come in and clean the coils. Actually, the general contractor did. And the next slide here actually shows that in particular, this one was missing a filter. So all the construction dust and everything went right into the coil, and you can see how it's just caked up. Well, this affects the owner and affects them, years down the line. So it's something to be aware of when you're walking around looking at stuff. And even as a test and balance contractor, make sure the filters are changed. Don't trust that the mechanical guy did it already. Just verify it, because that's very important. So, and the last slide that we have on our presentation is about being proactive in our inspections. And we've been saying it the whole time, is get out there during the construction process, flag issues like poor ductwork, blocked access, anything that could affect test and balance before they arrive. And the other thing is, it's gotten big for me, is involve test and balance into the commissioning meetings. A lot of times they'll get invited to the initial kickoff meeting, and then you'll never see test and balance again. They won't even show up to the red zone meetings or last meetings because they're not invited. Nobody tells them, hey, you should really come. So what we try to do is we try to involve test and balance early. We try to involve them during the project, but also if you find out test and balance is on site and out there doing test and balance, go out and talk with them, see what issues they have, because sometimes they'll tell you a bunch of issues that they may have, or maybe you can feed them the issues that you've been seeing and give them a heads up so everybody can work together as a team. The same goes for the controls contractor, kind of bring the 3 of them together, maybe even just have a meeting with test and balance, you guys, the commissioning provider and controls contractor, and talk about any issues that anybody has seen or concerns that might be out there that could affect test and balance or slow up test and balance. Because obviously we all know it, test and balance is the last person in, and then we follow right behind them. So, it's important that they have a very fluid process so they can get done. And then hopefully they don't pencil whip a report because they're just trying to get it done.
Yeah, I would say we can't stress enough that importance, what Gary just said about, talking to the test and balance team and involving them as early and as often as you can, because you just cannot rely on the GC or the mechanical subcontractor who might hold their contract to make sure that they're invited or they're included. We had a situation literally yesterday where we showed up for functional testing after many meetings the last couple of weeks, ready to say we're ready. And test and balance wasn't there because nobody told them that we were testing that day. So obviously that made the day pretty short.
Yeah, and especially it wasn't local, so we drove and then had to turn around and drive back. So it was a little bit aggravating for our team, but it's something that happens because we don't communicate a lot of times. A lot of us don't. We just need to be a big partnership, and it goes to the information sharing. Don't be shy to provide the information if you see some issues or concerns, or call up the test and balance contractor and talk to them. Be like, hey, I noticed this on the job site. What's your thoughts? What do you think about it? Because they're experts too, and they see a lot of things just like we do. And sometimes it helps to get a second opinion on something, or a view of what might be going on a project. So I guess we can roll into questions, Mark, unless you got something.
Nope, I saw there's some questions in the chat. Cassie's gonna lead us in the Q&A.
Yes, thank you so much for that presentation, Mark and Gary. That was great. Um, we have a couple of questions coming into the chat. This first one says, a lot of times current CFMs are not available on the BAS. When verifying the tab report, how do you get CFM readings from diffusers?
So I'm trying to follow exactly what that means. Because the CFM should be on the BAS if the BAS is functioning properly. But maybe it's meaning that you don't have access to the BAS, which would make sense. So typically what we see is when we're verifying it, the test and balance contractor is with us, and so is the controls contractor. That's the only way that really we can verify it together. Hope that answers that one.
All right, this next one is a comment. It says, a lot of issues can stem from tab being forced to start early by the GC or the MC. In most cases, this ends up doing more harm than good, but it's hard to make folks understand this. Do y'all have any ideas about that or any thoughts on that?
Yeah, so that's a big issue, and I have a big issue with that. And it goes down to the whole project itself, even for the controls contractor being forced to start before the VAV's even installed, tell them, hey, we need air, but you don't have air. Unfortunately, it's a battle that we're always going to have to fight. So, unfortunately, there's not much to do except work with the team and say, hey, this is not feasible. You can't start this early or we're not ready. And then keep stating that. And again, use the commissioning agent to help push that fact.
We try to, in our commissioning meetings, we always want to make sure that some of those important milestones are built into the construction schedule, right? And test and balance is obviously one of them, but there's a lot of things that drive test and balance. They can't start before ceilings are in or before, critical cleaning is happened or so those things need to be discussed as much as often as possible. Yeah, just to try to bring that up as early and often as we can. And then the poor test and balance guy has, a 1 week window to do, a couple 100,000 square feet of building, which would take a month to do. So we feel their pain.
All right, another question says, do you start FPT with a preliminary tab report to start flagging issues early, or wait until the tab report is approved by the EOR, which pushes commissioning closer to turnover date?
So this becomes that part of the test and balance is the last people. We're the last people. So we do take handwritten draft reports just because we do need to get started. But at the end, we do want to have a final report that shows us everything. Typically, because most people are using report software now, it's very quick for them to do a generate and give us a report. So yes, we will start on a draft report, basically.
This next one says, I usually scrutinize the tab fairly closely without going back to the job site with the tab contractor to spot check certain areas. How would we as the CXA know if the tab contractor actually confirmed the airflows, temperatures, etc.?
You don't. You have to trust them. I mean, and that's the whole thing. You have to trust that they are professionals. They did their job. But you have to physically put your hands and be there to do a verification, in my opinion.
Right. That's why we spot check, at the very minimum, spot check, with the tab guy, during functional testing or early in functional testing, and we randomly pick, here, let's go to these diffusers to these boxes and let's look and see what we got. And if it matches, great. But when it doesn't, then that, okay, now we need to look at it a little bigger, a little harder. So we don't trust, but we verify.
This question asks, as commissioning, aren't we supposed to observe a certain percentage of tab efforts as they are executed?
Mark, I'll let you take that one.
It depends on your contract, obviously. We like to, like I think Gary mentioned, just being on site during the construction and we want to talk with them if they're not during the meetings or, we want to talk with them about that. So if we know when they're starting their efforts, and we can, yeah, we'll be on site to watch some of that. But what is more typically happening is that we'll do that verification, like I said, when we start the functional testing.
All right, next up, this says you had an IR photo of a coil that was missing flow through it. I've seen 3 such cases with coils in the last 5 years. Is this more common of a problem than we realize? What's your experience with this issue and how often?
So I've heard about it, that it's been something that's been happening. It's the first time I have ever experienced it. Usually I hear the mechanical contractor caught it first or the test and balance contractor caught it, usually because when they start doing their flow, their calibrations for flow, the coil can't do what their flow is designed to do because it's missing half the coil. It was the first time that we saw it, and we only saw it because of the test and mount. When we were actually doing verification, we had a regular just IR gun that we were kind of shooting the temperatures and noticed that certain parts of the coil were warmer than other parts, and that's what prompted us. So, but I heard it's pretty common, or it's becoming common.
Other than like Gary said, now it's part of our checklist, and it's a part of our functional test to do some of that verification.
This person asks, should Tab be owner hired as an independent worker rather than under the contractor?
Absolutely. Yeah, I'm a strong believer that it's better to be hired from the owner because then they have the owner's best interest in mind and they have a little bit more control of the situation. So, yeah.
Another question about one of your examples. It says in the FLIR camera example, I thought I heard that the IT room without its normal thermal load was cool. So what were the symptoms that prompted you to bring out the FLIR camera?
So it was basically, like I said, when we were doing the tab verification, we had a regular just IR gun, one of those point and shoot kind of temperature guns, and we noticed part of the coil was warmer than the other parts of the coil. And that was the only reason we ended up breaking out the flare gun to double check what the actual coil was doing.
Yeah, it was hard to tell just from the temperature in the room. I mean, it was cool, like Gary said, it was cool-ish, but it's still a construction site and there's stuff going on. So you could tell there was cold air coming out of the coil, but you know, we have found, not surprisingly, that having the flare gun or doing any kind of just spot checking some things, you know, it can lead you down a rabbit hole, but there's a lot of stuff you can see just with some quick shots.
All right, this next person is asking about a percentage of errors during the tab verification that you would still accept, I think, was the maximum percentage of errors during the tab verification will make you accept the work. Do you have any insights on that?
Yeah, so if I see one failure, it's failed. No, typically we're very lenient about it. So we're checking, you know, different areas, but if we see a pattern of constant percentages that are way off from design or from what the tab report says, we're going to start asking questions like what's going on, you know, why are we having these issues? We'll maybe add some more spot checking or more to our sampling until we become satisfied that the building was balanced correctly.
All right, next up, this one says, tab verification is generally hard to reproduce as you're there for a minute or two. Do you ever use trending to verify?
Yeah, absolutely. Trending is another portion of our arsenal. It leads into the connected commissioning that we were talking about because that gives us more of an arsenal. But we do ask for trending for every box at the end of the job or when we're finished up with test and balance verification.
Next up, have you had instances when tab wasn't done right because programming wasn't complete, and how do you deal with those situations?
So that is one of the biggest problems that happens. There's a lot of finger pointing between controls, tab, mechanical. We do see a significant where controls didn't do their proper checkout, controls didn't do their proper programming, or test and balance was done and then controls went back and modified something. So it is pretty common to see. And unfortunately, the test and balance contractor gets stuck in the middle of, is it ready? Is it not ready? And that's when we have to come in and kind of evaluate the situation too.
All right, thank you all for submitting questions. We've got some more coming in. Next up, for boxes that don't have airflow monitoring stations and therefore don't have the CFMs shown on the BMS, how can you verify airflows against the tab report without having the hood with you on site to confirm airflows?
Well, we can't, obviously. So we typically would have to have a hood with us to confirm it. There's no other way. We're going to use the BAS, but if it's not available on the BAS, then it would have to be a hood to confirm it.
Right. Gary, it's worth mentioning that I'm looking at these Q&A comments, and there's more than one that wanted to know what's going on with the dog in some of these.
I was waiting for Cassie to ask that question just because I was going to chuckle. Mark puts a lot of Easter eggs in his presentations, so I felt I needed to follow suit. So I put a dog in multiple portions of the presentation, And I'm really happy that people caught on to it because
That means you're paying attention and
Right.
are actually looking at the picture. So that
thank you
one
for
with that one with the guy, the test mouse guy with the two by two hood, it really looked like it was his dog that was just sitting there in front of him.
I was
Sorry,
holding off on that question, but I'm glad you brought it up. I was
sorry, Cassie, I
curious.
couldn't
No,
help.
no, you're good. This person asked, can you explain connected commissioning a little bit more? What are costs to get connected commissioning?
It varies. It's a per project kind of thing. I don't want to tell you a bunch of numbers because they don't mean anything because every project's going to be different. But typically, if you partner with somebody, a business that does it, they work with you and they can come into your budget or come into what the project needs are. And as a commissioning provider, it's really helped us enhance our commissioning, what we provide to everybody. So.
Follow up to the dog question said, did the dog balance that project? Might explain things.
A little bit. Well, he probably would have done a better job, but
Another question says, at what point would you draw the line and request that tab needs to be done again if you're seeing a lot of errors?
so typically we wouldn't draw that line. We would just end up having a meeting with the construction team and the owner and say, okay, these are what we're finding. These are the issues. We really need to talk about it. And in one of the situations with the gentleman who was using the 2x2 hood on the 4-foot linear, we actually gave them the opportunity to come out and rebalance this building. We noticed they weren't rebalancing it right. We brought in another tab contractor and had them do a double check without them knowing, and we ended up finding out that everything was way off. And we just ended up hiring that tab contractor to finish out the balance.
It's admittedly an unusual situation, but yeah.
Another person's asking if you could explain a little bit about the importance of tab balancing procedures and scenarios specific to the project being included in the report for purposes of repeatability.
So it's important in the beginning of the report, or even when Test Amounts submits a submittal, it's important that they put in how they plan to test certain things because these systems are becoming more complicated and more unique. So the Test Amounts contractor has to have an idea how they're going to actually balance the system out. And it's important to put it in their report and have it listed. And it also is important to have it in their final report saying how they really did it, because just because you plan to do it one way doesn't mean that's how it really happens. I hope that explains or answers that question.
All right, I think we've got time for one more. This one says, during commissioning, what kind of measuring tools do you use? Are they calibrated and certified tools?
So typically we don't use our own tools. We actually, again, we're with the Test and Balance contractor. So they're going to have the calibrated tools and the proper measuring devices. Just because that's what was used on the project, we prefer them to be the ones doing it.
All right, one last comment from an attendee says, my most perplexing tab showed flow through the valve project was resolved by finally having the contractor pull a valve and find out the ports hadn't been milled out at the factory.
Yeah, I've seen that. I've actually seen a fire extinguisher stuck in a pipe before too. Those will cause a lot of flow issues, but yeah, that's a good one.
All right, well, that is a wrap for today's webinar. Thank you both so much, Gary and Mark, for your great presentation and discussion. Thank you also to Ameritech Data Solutions for sponsoring today and for everyone who attended and asked great questions. Before we wrap up, I want to let everyone know that the call for abstracts is open for CX Energy 2026, which is happening April 21st to 24th, 2026 in Chicago. Presenting at CX Energy is a unique opportunity to share your expertise, showcase real-world solutions, and be part of one of the industry's most respected technical programs. If you've got an idea for a presentation, we want to hear from you. Learn more and submit your abstracts at cxenergy.com. And until the next webinar in this series, stay well and thank you for your time.
Thanks, Cassie. Thanks, everybody.
Thank you, everybody.